school when times were good, okay? You were given a piece of pizza. And they were like, there's something called a fraction. And you're like, what? And they're like, yeah. And then they're like, you eat one piece. This pizza is cut into 4. And you would tell me, how many pieces did I eat? 1 out of 4. And you guys were like, wow, this is amazing. And then your teacher said, guys, that's not all. We're going to cut these. I should teach elementary. I just would be so good at this. So bad. Okay, guys, we're not done. What happens if we cut all of these pieces in half? And then you'd get the little kids being like, we'd have more pizza. And you're like, no, that's not well cut in half, but pretend. They'd be like, they have more pieces, yes. But would they have more pizza? No. They would have how many pieces now? They would have 8 total. How many pieces would they have? 2. And we're old enough, so we know that 2 out of 8 pieces, this thing sucks so bad. I need elf ears. 2 out of 8 pieces is not better than 1 out of 4, unless, of course, you want to believe that you have more pizza. Then 2 out of 8 is better. Like, and I have more pieces, but in actual area of pizza, you do not. What are these 2 fractions? Equal, which is called equivalent. Yes, they're equal. So what did we do? What did we do to go from 1/4 to 2/8? We doubled it. We doubled what? Just the top? Whenever you do the top, you do the bottom. You learn that in elementary school too. So much elementary thing. So if you multiply the bottom by 2, you have to multiply the top by 2 in order for it to remain equivalent, right? If I just multiplied the top by 2, I would have 2 out of 4 pieces, and that's half the pizza. That is not equivalent. Correct? More pizza? Not right. Okay. So 2 out of 8. We agree? Now, if I want to go from 2 out of 8 to 1 out of 4, what could I do? I could divide by 2. So equivalent just means I have to do the same operation to the top and the bottom by either multiplication or division. You can't just add or subtract. To make equivalent, you have to actually multiply or divide. Okay? So we're going to look at B. Write a rational expression that is equivalent to 4x squared plus 8x over 4x. If I want equivalence, I have to either multiply the top and the bottom by the same thing or divide the top and the bottom by the same thing. Every single person do your own equivalent. Try it out. You can multiply the top and bottom by 2, multiply the top and the bottom by x, take out an x from the top and the bottom. Try it out. Every single person might get a totally different answer, which is fine. This one here, I want you to give me an equivalent rational. Your choice. So what we could have done is we had 4x squared plus 8x over 4x. We could multiply the top and the bottom by 2. If you multiplied by just a 2, it would just change the coefficients, the numbers in front, right? So 4x squared times 2 is 8x squared. 8x times 2 is 16x over 8x. We could have done that. We could have divided by 2 and an x. As long as we did to the top and the bottom, it has to come out of all terms. So divide by 2x. Could have done that. So 4x squared divided by 2x is just an x and a 2. Plus 8x divided by 2x is just a 4. And then 4x divided by 2x is 2x. The x and taking it away? Yep, just a 2. Okay, now, how would they do this to make it so that not everyone could pick whatever the heck they wanted? Get off your phones if you're on a phone. So, we have this expression, 4x squared plus 8x divided by 4x, okay? What they could say is an equivalent expression of the same form would be ax squared, or ax, let's say, plus 2 over 1 over b. They could say that. And then they could say, what's A and B? All right. What's the only thing they gave you? 2. The 2 works with this one. So what did they do? They divided by 4x on the top and the bottom. So that's how they can force you to divide it by a specific amount. So 4x squared divided by 4x is 1x. 8x divided by 4x is plus 2. 4x divided by 4x is 1. So they could say, write A in the first column and B in the second column. Or what's the sum of A and B? So what are they actually asking you to do then? The sum of A and B. The sum. Add them. So it would be 2. So they could ask you to put them in the first and second column. Then it would be 1, 1. They could ask for the sum, which would be 2, because it would be 1 plus 1. All right? What are the NPVs for this one? We have a 4x in the denominator. Are those added together or subtracted? No, so they're in their own brackets. So can 4 be 0? No, so it's not going to give me an issue. I just have an x. So my NPVs are just x cannot equal 0. Example 4. For each of the following rational expressions, this is another way they can force you to do it one way. Expressions, determine if they are equivalent. So we can either go, this is 9 3x minus 1 and negative 18 over 2 minus 6x. I'm going to compare the monomials because they're easier to figure out. So I can either say, hey, how do I get from negative 18 to 9? I divide by negative 2. Or I could say, hey, how do I get from 9 to negative 18? Multiply by 2. Either one would work, just to see if you get the other, correct? Most people will pick multiplication, so that's what I'm going to do. So we have 9 over 3x minus 1. What do I do to 9 to get negative 18? So I'm going to get 9 times negative 2 is negative 18. Over negative 2 times times 3x is negative 6x. Negative 2 times negative 1 is positive 2. My answer is negative 18 over 2 minus 6x. Are these the same? Can I switch these? If I gave you 3x squared plus 4x minus 7, could you have written it like this? 7 plus 4x plus 3x squared? Yeah, you can move them around all you want. You just have to make sure, oh, it's a negative 7. You just have to make sure that you take the sign with it. Okay? So this one I could rewrite as negative 18 over positive 2 minus 6x. You just have to take the sign that's in front of it with it. And they actually match. So they are equivalent. You try B. So I'm going to change the first one. 2 minus 2x over 4x. So I want to get 4x to be 2x. Put them down. Put them down. So what do I have to do? Divide by 2. Could I have multiplied the other one? Yes, I'm just showing that you could do it to either. So 2 divided by 2 is 1. Negative 2x divided by 2 is negative x over 2x. So I have negative x, positive 1, negative 1, but these match. Not equivalent. Okay, we have one small thing to go over. Okay. In each case, write a rational expression with a given variable and the certain particular non-permissible value. So if it says it has a non-permissible value at 3, that means x cannot equal 3. So I have to work it backwards to get it back into not equal to 0 so I can put it back into my equation. So I'm going to move the 3 back by subtracting it. I'm going to get x minus 3 cannot equal 0. So I need to have that in the denominator of my rational expression. I'm using x's because it said the variable is x. Now what do I need in my numerator? Anything. Because right now the only thing it tells me is I need to have this specific restriction and a specific variable. So I could put a 7 up here and I'd be golden. I'd be done. I could put 7x squared plus 3x minus 14. I could put 1 million. It would be fine. I just need to have an x and I need to have a polynomial on the top. The variable is a for this one. My non-permissible values are 0 and 4. This one's done already. If I have a 0, what do I have in my denominator? Just a x. But then I also have this cannot equal 4. So x minus 4 cannot equal 0. So I also have an x minus 4. And then I can have any type of polynomial on the top. X squared plus 3. It doesn't matter. You could have just a 7 up there. Yeah. So it just depends on what format they want. I would just leave it like this because it's not asking me to. But if it said it has to be in a specific form where it was distributed, then you distribute it in. Okay, C is the hardest one I can give you. It has a third. So I have the variable p. P cannot, oh, I didn't use the variable a. That's bad. These need to be a's. Okay, I don't remember what I had at the top, but that's fine. Okay, this one is p equals a third. You can't go p minus a third. How do we undo the third? Multiply by the 3. 3p equals 1, and then minus 1. 3p minus 1 cannot equal 0. So that means it has to go in my denominator. So I'm going to have 3p minus 1 in my denominator and something in the top, like 6. 6p plus 8. Okay. And I'm going to hand out your